Hello, I am Dennis Nixon, and I'm going to introduce you to process thinking in this brief presentation. At a high level, a process always begins with somebody wanting something. We call that person the customer. Then there are various resources that the person providing the customer request uses, changes them in some way to get a result out that is what the customer wants, and then the customer need is satisfied. Let's use a simple example. The customer, in this case maybe your spouse, wants a cup of hot coffee black. You use various resources: a filter, ground coffee, water, kettle, coffee pot, cup, and maybe you're going to be the barista. Now the changes that take place is that you've got to put ground coffee, a certain amount, into the filter, and then you've got to pour boiling water through the coffee grounds in the filter into a pot, and then you're going to add it to a cup and then deliver it to the customer. And then the results out are that coffee is served to the customer, and they got what they wanted, which was a cup of hot coffee black. If we drill down a bit more into a process, you'll recognize that there are a number of steps, and we call these action steps, and they are the unit of a process. Now, an action step itself is a process because it will contain a certain number of steps. And those steps are usually various actions that are taking place. Either somebody is doing something or a machine is doing something, but this is where the changes are occurring. So why do we do all these actions? The purpose of a step is to change the input, and by doing that, they're adding value. Value is what the customer says it is. Now, in the coffee example, you had materials that were being used, and inputs to a process, however, could be information, material, or energy. And as the information is changed, or the material is changed, or the energy is utilized in a particular way, that's where you're adding value to what the customer is looking for. Mapping a process is a very useful exercise. It gives you an overall view of what a process is about. So these are the action steps for making filter coffee end to end. So the spouse asks for the coffee, you select the coffee type, and you take that out of the cupboard. You select a filter, you open it and place it in the funnel that's above the pot. You open the ground coffee container, you place a measured amount of coffee in the filter. You close the coffee container and return it to its storage spot. And then you add water to a kettle and you boil the water. And when that happens, you pour water over the grounds, and the water goes into the pot that the filter is standing on. And then you find a cup and you pour the coffee into the cup, and then you serve it to the spouse. So these are a high-level look at the steps that you take to transform a customer request for a cup of black coffee into it being delivered to the person. So while I showed you the high-level action steps, in each one of their steps there are actually other steps that go into it. So if I had to map out this process fully, I would have to include that you walked to the kitchen, you opened a cupboard, you searched for the right coffee. Maybe that entailed moving some things out of the way or picking up several things till you found the right coffee. It included opening drawers, opening boxes to remove a filter, closing the box, returning the box, opening the drawer, getting measures, and measuring the ground coffee. So that might be a spoon of some type that you're using. You have to get the spoon. You have to dip it into the coffee grounds. You have to move it across and put it in the filter. You've got to pick up the kettle and move to the faucet and fill it with water and then go back again and plug the kettle in. And then you have to wait for the kettle to boil. Waiting we'll discuss in some detail later, because nothing's happening there that you were doing, but the action is that the water is getting hotter and hotter and hotter until it bubbles and is boiled. And then you might pick up the kettle, carry it to the filter, return the kettle, wait for the water to move through the filter, clean the measuring spoon that you use, return it to its storage spot, and then finally you're going to walk to give your spouse the coffee. So there's a delivery aspect to it. And there are probably 100 more little steps that you could observe in the making of filtered coffee. So when we look at value added, we can say that value is added when something is changed in a way that the customer finds meaningful. In other words, it contributes directly to customer satisfaction or the intended outcome of the process. Second one is that the customer is willing to pay for the result of the step. So if you ask the customer to pay for the time you spent selecting the filter, opening the coffee grounds and putting it in the filter, you would say, look, that's not my problem how you do it. All I want to pay for is the result, which is the coffee delivered to me. The other important thing about value added is that value is added when it's done correctly the first time. So if it mustn't need any rework or correction. So these three things, it's changed to what the customer wants, which they're willing to pay for, and is done correctly without needing rework or correction. So if we now go forward and have a look at where are the value-added steps in this coffee making, we find that there are 4 steps in the process that are actually adding value. The first one is selecting the coffee type. It's possible that you have 5 different types of coffee: decaffeinated, espresso, Venetian, French type, and selecting the one that your spouse wants, that adds value. Second one is pouring the water over the grounds. This is the first time the water actually starts changing to become coffee. So it's value added because your spouse wants coffee. Now, your spouse also asks for a cup of coffee. So getting the right type of cup for your spouse is added value. And then finally you serve it, which is delivery. And that's the final step, and that's valued. So these 4 steps, if we put them together, are the value-added steps in the coffee making process. And one of the things about process thinking is that once you know what the few steps are that are adding value, you can start imagining what would it be like to actually redesign the process so it was value-added steps only. And this is where I want to introduce you to a Swiss gentleman. Eric Favre was a Nestle engineer, and he had a wife, Anne-Marie. And Anne-Marie apparently was complaining to him about what she considered to be tasteless Swiss coffee. Now remember, Nestle is really into coffee and selling coffee and so on. So they decided they were going to visit to Italy because Anne-Marie had mentioned that the coffee in Italy just tastes great. So it was 1975, they visit Italy, and espresso machines are in full swing there. Espresso machines were actually invented to speed up the length of time it took for coffee to be made for clients. But what Eric found was that there was so much flavor in the coffee that he was really impressed with it. And so he started thinking about, how can I invent something that we get this great flavor without having to use filters and ground coffee and so on and so forth. And in 1976, he patented what he called a capsule. And basically what it was a little container with coffee grounds in it that went into an espresso-like machine, and the water pushed through the grounds in the container and made the coffee. So he brought it back to Nestle, but unfortunately at this time, Nestle were heavy into having invented instant coffee, and everybody was buying instant coffee. It was flying off the shelves, and they were just making a lot of money out of it. And in fact, for 10 years, they didn't do anything about Eric's invention. But then in 1986, they launched some machines with things they called in those days K-pods. And these machines were quite cumbersome. So the market that they defined for their product was basically restaurant kitchens and also office kitchens where people could make these coffees. And it took them quite a bit of time, about 2 or 3 years, for them to come up with a smaller machine that would be good enough for consumer use. And they did this by licensing third-party manufacturers and so on. And so from 1990 onwards, this really became a big thing for them. And you might know the name Nespresso, which is obviously Nestle and espresso crunched together. So Nespresso became their big product, and there are now thousands of different flavors of coffees, and all over the world people are picking one of these containers and putting it in a little machine and making coffee. So back to process thinking. What actually happened here is that the spouse asks for coffee, the barista selects a K-pod or a capsule or a coffee pod, those are other names for it. So they select the K-pod, they put it in the machine, press a button, and it drips coffee into a cup, which is then served to the spouse. So what they actually did here, without realizing it, was they compressed the whole process of coffee making into 4 steps. Even though that wasn't their intention was to make better coffee. Here you can see the number of steps that are eliminated by this new system. So combining an espresso machine with pre-packed coffee grounds, and they also ended up with this yummy flavor, which was what Eric was trying to achieve. But using coffee pods eliminate these steps. So if we map the 2 processes, here they are side by side, with 5 high-level steps in the Nespresso, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steps in the original filter coffee system. So the moral of the story is process thinking can lead to the invention of new products and businesses, or solve problems like taste and speed. So let's look at a basic manufacturing process. And basically here you're going to have raw materials coming in, they QA'd and stored, you have a production plan, and then you start changing the raw materials through machining or assembly or something, and then you QA them afterwards, check that everything's okay, you package them, you store them, and then deliver them to the customer. And again, when we look at value-added steps, it's really the machining and or assembly and delivering to the customer that's important. I want to shift gears now and look at generic processes and times. And the first time I want to talk about is throughput. So in this diagram here, you have your resources in, and you have the 6 process steps. The black numbers in each one of the post-it notes is how long it takes for that step to actually be done. And then you get throughput. I'll talk about the TT and the cycle time later. So throughput is the rate at which items are produced. In this case, they produced 1 every 10 minutes. And the reason for that is that you can see there's one step number 4, which is 10 minutes. And you can't get anything out faster than every 10 minutes because of that, what we call the constraint. So the throughput here is a rate at which items are produced, in this case, 1 every 10 minutes. The next one to look at is cycle time. And cycle time is the total time for one item to be produced, measured E to E, which is abbreviation for end to end. In other words, from customer to customer. And in this case, cycle time, you can say, is about 35 minutes by adding up how long each step takes. Now, it's not quite as simple as that, and we'll look at that in some more depth. But that is what cycle time is. If you put something in the very beginning of a process, how long does it take to come out the other side? The next very important aspect of process thinking is to think about waiting time. Waiting time is when no action is taking place on the materials, information, and so on. In other words, nothing's happening. It's not been changed in any way. And the next thing I want to share with you is this idea of constraint. Constraint means holding back. And the constraint is always to throughput. So we're looking here at if we want to increase the rate at which we are approving applications or assembling cars or completing reports, then we look for what is the longest step in the process. Because the longest step in the process is what dictates the speed at which throughput takes place. So in this case, the longest step is 10, and therefore the throughput is only once every 10 minutes. There's a link below to a simulation where you can fool around with the different lengths of time in a step and see how the throughput changes as you make alterations. But remember, there's always a constraint in a process. If we improve step 4, for example, by halving it, so now it only takes 5 minutes, there's still a constraint, and the next constraint is step number 2. And therefore only one item every 8 minutes will come out, even though you've halved 10 down to 5. And you'll start getting a change in waiting time as different backlogs build up in different areas. So the next thing you do then is go to step number 2, if you want to still increase the throughput and improve that. And let's say you get that down to 4. Now you've got 2 constraints. You've got number 3 and number 6. If you improve number 6, it's not going to make any difference. If you improve both, then your constraint will be somewhere else. If you get it all the way down to every step only taking 1 minute, now you've got a constraint in the whole system. So if you want to improve throughput now, you've got to look at touch time for each individual step, see if there's anything that can be improved there. And you're going to have to do it right across the whole system, because if you improve 5 steps and get them down to, just half a minute each, but 1 minute is left, you haven't improved any throughput. So throughput's a really interesting thought to play around with, and the simulation will help you do that. As an aside, I thought I would share with you that process thinking also works at the very highest levels in organizations. So let's talk about strategic constraints. Organizations are systems with a whole spaghetti mix of processes, and they live in what they've now called a VUCA world. And we know that it's volatile, uncertain, complex, ambiguous. Things are changing rapidly. Think of AI, think of climate change, think of the political changes. And we've said that each process has a constraint to throughput. Organizations have constraints in their systems, primarily to growth in earnings. And fixing that requires processes to remedy it. So let me give you an example. A constraint to growth in earnings might be a competitor gaining market share at your expense. So once you recognize this, the challenge then is to talk about what's our strategy going to be to resolve this. And once you have a strategy, the strategy has to be implemented through processes in the organization. And here's the really important thing. If the capability of the processes to achieve the strategic objectives is not adequate, then you've got to redesign that process at the root cause level to see how to change it so your strategy can be implemented. So think about it this way. A system is a really high level way of looking at processes. In other words, the market, the economy, the climate, all these things in the VUCA world that are affecting a company is because the company is made up of a whole lot of processes that are playing together with this VUCA world. And if those processes aren't giving you the results, you look for the constraint. What is causing our growth to not be as great as we wanted? What is causing our growth to be slowing down? What is the risk that we are facing that we can see is going to have a big impact on us? So those become the constraints to the system, which is the company. But for that to be resolved, the company needs to create a strategy, which in a way there's a process for creating strategies. But they create a new strategy. Now they've got to implement it with the same company, the same processes that exist. And if those aren't good enough, they've got to find out which ones are constraining them from implementing the strategy and then take it forward. So as an aside, I want you to appreciate the constraints are clearly understood in a manufacturing process. They certainly will be easy to understand in an administrative process. Constraints might be the time to get authorizations. The constraints might be on waiting for information, all sorts of constraints, but basically they're relatively easy to identify. And until you fix them, reduce them, dissolve them, you're not going to get an increase in throughput. The next aspect of process thinking is thinking about waste. So waste is anything that doesn't add value. So if you have a defect, obviously that's waste because you've got to throw it out, replace it, make a new one. So certainly Toyota has looked very clearly at waste, and one of their big pillars is constantly reducing waste for two reasons. One, to increase quality, keep customers happy, and the other one is to reduce costs so that they can provide their quality at a reasonable cost. But every single process in an organization has some degree of waste. Dr. Deming said that he estimated that there was 86% of waste in organizational processes. And that has been proved over and over again, that if a process has not been studied for improvement, there's probably about 86% of it is waste. An improved process is going to be less, but even a process like filtering coffee, if the objective is to make the coffee, you could see that there was waste. There were steps that were unnecessary. You could reinvent them. You could create an espresso. The question next becomes, where is the waste in espresso? And one of the waste is obviously the container, because the container is used once and then disposed. So every process has some waste in it which can be looked at. And waste can be time, as we've discussed. It can be energy. Think about the discussions that are going on at the moment about the huge amount of energy that is needed to run these server farms that are necessary to answer your questions on ChatGPT or on Perplexity. The other one is movement. Sometimes something is just carried 20 yards, and that carrying it 20 yards to get to the next step is really waste. Is there a way of doing it that you reduce it to 1 yard or no yard? Or is there a way of moving it that is much faster? And so on and so forth. Obviously on materials there's waste. If a manufacturing plant is cutting out certain shapes from a sheet of metal, there's going to be some little pieces of the metal left over. And designing how they can cut out their pieces to reduce that amount of waste is important. Information can be waste as well. One big one is like asking for the same information over and over again, instead of somehow asking for it once and then it's there and available to you whenever you need it. And then of course consumables, things like oil and various chemicals and whatever. There's waste involved in that. So simply put, any resource that is used without adding value, there's waste there. And just to remind you about value, that it's changed in a way the customer finds it meaningful and it contributes directly to their satisfaction and they're willing to pay for it. And you want it done the first time without needing rework or correction. So if you're going to bolt in a bolt into a car that is being built and it has to be at a certain torque, a certain strength of turning it in, So if you can just turn it in and the torque is correct and you do it once and that's done, that's perfect. But if you screw it in and then you measure the torque and it's not right, got to screw it in a bit more, measure the torque, it's okay. The second time you did that, that is waste. You can Google the various types of waste, and there are a lot of them. Here are just some examples of common waste. Time, defects, non-quality outputs, non-value added steps, rework, non-quality materials coming in, errors, backlogs, a machine shutting down for some reason, somebody having lack of skills and not doing the work well. A constraint is waste because they are overproducing ahead of the constraint, and after the constraint, people are waiting around waiting for the constraint to deliver what it needs to deliver. And then overproducing. You could argue that the ideal warehouse is one that has nothing in it. That's not a reality that one can live with, because there'll be variation in demand from customers, variation in supply throughput, and so you need, the right places, you need buffer stock. So even in just in time, there are a number of areas where there's a bit of buffer stock to just ensure that variation does not stop the whole of assembly. And we mentioned before excess inventory, unnecessary movement of materials and people. So I want to share with you now how you can take process thinking into even something like having a shower. I'm always looking for processes that I'm doing, using, and finding ways of doing it better. And I get satisfaction out of that. I hope you would. But here was a case where I knew that I was wasting water when I showered. And I decided to have a look at how could I save water. So I did research. On average, 0.2 liters of water comes out of a faucet that's open full every second. And I calculated that I used 60 liters of water during the time I was showering. And that's a lot. If you think about a liter of milk and imagine 60 containers of milk, that's a huge amount of milk. So I started breaking down my process. I obviously mapped it out. What do I do? How do I shower? And I've got to admit that I shower pretty simply. I don't have dreadlocks. I don't have long hair. I don't have thick hair. So washing my hair doesn't take much time. However, I've got to wash my hair and I've got to wash my face and my body and my feet and everything. So I mapped out how I did that. And then I started looking at how could I improve that process. So I'll give you an example. For me to wet my hair is really a very short, because I don't have a lot of hair. But I used to turn on the shower and then wet my hair and then shampoo it. And then when I was finished shampooing, we'd get under the water again and get rid of the shampoo. But now what I was going to do was wet my hair, switch it off, shampoo my hair, there's no water running now. And then when it was shampooed and I wanted to now get rid of the shampoo, I would turn the water on. But I also wondered whether I needed the full blast of water coming out of the faucet. So I experimented. In fact, I only need to turn the faucet on about halfway. And that would give me enough flow of water to get rid of the soap in my hair. So that became my new process. Wet my hair, switch off the faucet, shampoo, turn the faucet on halfway, get rid of the soap. I also found that halfway was plenty just for wetting my body, which I would wet before I soaked. And then the way I had of soaping my body, I'd been on a trip to Japan and I noticed in the hotel their, what we would call in Canada, a face cloth, but the cloth that you would use to put soap on it to soap your body was quite interesting because it was quite rough. It was quite, the thread was quite open, and I'm not quite sure, I haven't looked up to see what they call it, but let's just call it a Japanese face cloth. That's what I use. So when I've finished wetting my body, I also wet the face cloth. I switch the water off, and then I put soap on the face cloth until there's enough soap there. And then I soap my body and scrub it where necessary. The beauty of this Japanese face cloth is that it actually gives you a bit of a scrubbing effect. So you're kind of scrubbing your body at the same time you're soaping it. And then when I've cleaned my whole body, I then turn the water on a little bit. I use it, when I say a little bit, about halfway. I use it to get rid of the soap that's in the face cloth, and then use it just to get rid of all the soap on my body. And then basically I'm finished. So I created a bit of a simulator, and I'll give you the link to the simulator, and it will be in your package as well, so that you can go and play around with it. And it's the simulator that I'm going to update, so people with dreadlocks or long hair or whatever would have more choices as to what they do in the shower than I do. But for me, what I did, and I now shower this way every day, is every day I'm saving 40 liters of water when I shower. So that in a nutshell is process thinking. You start off with what is it that you want to fix, look at the process, take some measures, think about how you could do things differently, try them out, and improve them. And that's the heart of process thinking, because every work we do, every piece of work, is a process. Another very important understanding of process is variation. And there will be variation in the output of any process. Dr. Deming was very, very strong on variation. And it can be quite a complex subject, but in principle it's very simple, so I'll walk you through it. So the first one is that there will be variation in output of any process. For example, if you buy a new car and you start using it, it will immediately start to wear out. And if you don't do anything about it, there'll come a time in the future when the parts are so worn out that your car is not functioning well at all. But from the very first day you get it, variation in performance is going to be started to be built into the system. There are two causes of the variation. Some of them are due to what we call common causes, and the variation is within acceptable limits. So we're not worried about it, it's working extremely well. So when we talk about limits, we talk about having an upper limit and a lower limit, and as long as the variation is between the two, then everything is good. So let me give you an idea of common causes and special causes. Common causes are just normal things in the environment. Let's say you're writing an exam and you're in a room with other people and it's pretty quiet, but if you're really focused, you could probably hear the air conditioning humming. You might hear somebody coughing. You might hear pens being put down or picked up or dropped on the floor. But basically these are common causes. There'll be noise in that room to a certain extent. but it's within acceptable limits because it's not destroying your concentration as you're answering the test results, right? But imagine now that somebody was coming into the room bringing, say, glasses of water and happened to drop them on the floor. So this huge crash, bang that you hear, that would be a special cause because now it's really distracted you and broken your concentration, and now you have to get back to it. So a special cause is something that's not just the normal day-to-day cause. As you look at variation in a process, say you're measuring it, and you're getting variation that's between the upper and lower limit, then you could say that the process is in control. And you could go about decreasing that variation if that you felt would make a difference. In that case, you're lowering the acceptable upper limit and raising the acceptable lower limit. But if the variation exceeds the acceptable, then you need to look and say, where is the special cause? What is causing this to go out of the norm? Sometimes special causes are a singular, non-recurring event, and there's not much you have to do about it to get back on track, because hopefully it's not going to happen again. So that person is not going to come in again 5 minutes later and drop glasses of water all over the floor. So you don't have to do much about it. But you could imagine if you were in a room and for some reason the air conditioning was whining and screeching and making really loud noises, making it difficult for you to concentrate, then yes, that would be a special cause because it's outside of the norm, and one should take some action with it. Complain about it, see if they can do something, switch the air conditioner off, or bring in a mechanic to fix it. But special causes can also be things that are here to stay. If you think about the iPod invention, it affected Sony's Walkman sales. If you're familiar with the Walkman, it was a portable CD player and a portable tape recording player in the days when tapes were how you bought music and CDs was how you bought music. And they were selling a lot of them. They made a lot of money out of it. And in fact, they started conditioning people that they could have music on the go. And then along came Steve Jobs, and he created the iPod, which in his words could give you 1,000 songs in your pocket. So he made it small, and he made it 1,000 songs, and basically that's it. Sony Walkman sales dived, and it wasn't going to go away anytime soon. So that's a special cause that's there to say. And Sony, if they wanted to compete with the iPod, would then have to take a strategy to do that. COVID arriving was another thing that came and didn't go away. And it was a special cause, but it was here to stay. So people had to make a lot of adjustments in their companies to keep revenue flowing and so on. AI is another thing that's coming in and is going to be here to stay. And we're not sure at this time exactly what it's going to affect and how it's going to affect it, but it's already affecting the world. In my case, for example, a very small example, I used Perplexity instead of Google. I find Google, which still gives you thousands and thousands of sites, which you've got to kind of work through it. Whereas I can ask Perplexity a question, and I'll not only get the summarized answer, but they also tell me where they got the answers from. So it's very specific to me, and I don't use Google at all. So I'm sure down the road, Google is going to be AI driven, and some of their algorithms and things like that will have to change, because reaching the top of their search output is where they make a lot of advertising money. So those are special causes. So I'll introduce you now to control charts, and you can read up a lot about these as well. This is a control chart in which the process is in control. You have your upper limit, you can see on the top right, your lower limit on the bottom right, and in the middle is your midpoint or your ideal. And the black dots are certain measures you made of the outputs. So you can see there's variation in the output, but that's all from common causes. This next control chart shows that it is in control, but I've marked the first 4 as being in control because there was something happening with the next 4. They're reaching towards the upper limit and they seem to be consistently there. So I would start thinking about, I wonder what's happening there. Maybe there's some special cause developing. Maybe some part of a machine is worn out and is beginning to reach the upper limit of performance. So even with an in-control chart, you might be looking at something that gives you an idea that, something's going wrong here. And then you get an out of control chart. Here you see that there are some instances of measures that went above the upper limit and above the lower limit. Now there's something going wrong. It's not happening every time, but it's happening. So there's some special cause that's causing this to happen. And you need to get to the root cause of what that special cause is and remedy that to bring the process back into control. We call a process that is in control, that's giving the same outputs consistently, a stable process. And it just makes sense that it's stable. Frequently when we run workshops, we ask people at the beginning of it their definition of a good process. And typically they will tell us that quality outputs, the output that you want, etc., etc. And then we fool around with them a little bit by saying, no, a good process is one that gives the same outcome every time, even if the output is unacceptable. And why we say this is that a process needs to be stable for you to look for the root cause of why it is not having an output that is quality. But at least you know that the same thing is happening in that process every time because you're getting the same output. So if you have an unstable process, you then have to first stabilize it and look for the root cause. Now practically, how does one do this? An unstable process, if it's involving, say, people and machines, there's something that's happening differently all the time. Somebody's doing something different, or they do it one way this time and another way another time, or they're just not following the process. So what you do is you simply create a process and demand that everybody follows it exactly as you've designed it, even if they're uncomfortable with what they're doing. Because what you want to do is just get one process giving you an output that's the same every time. And then you can start looking for the root cause. So if you have an unstable process, you firstly need to stabilize it and then measure the results, and then you can start looking for the root cause. Sometimes when you stabilize it, the output is exactly what you want, and you solve the problem by finding the cause of instability. But if the output is not acceptable after you've stabilized it, then you want to find the root cause. And the root cause is basically that action step or steps which are the cause of the non-quality result you're getting. And once you've found that, you then invent what we call an elegant solution. And an elegant solution we'll talk about a bit later. Kangaroo solutions. Kangaroos, you know, the one thought you have when you watch a kangaroo is they are jumping, jumping, jumping. So quick fixes and jumping to solutions are kangaroo solutions. And one of the basic rules in doing process redesign work is that you don't even think about solutions until the root cause is known. If you're not solving the root cause, then whatever you do might bring about a little bit of an improvement, but it's not going to solve your problem. So no kangaroo solution. It's also important with processes to realize that some problems are simple ones. If you have a leaking faucet, for example, you kind of know what the cause is. The washer inside is worn, or something inside is worn, and you need to change that. So you go ahead and you change it and you've solved your problem. You don't have to map out the process and find the root cause and run experiments and so on. Beyond simple problems, you get what are called complicated problems. And a complicated problem is one in which you kind of know that there's a root cause of the problem. You just don't know what it is. With many of our clients, they have been grappling with a problem, normally in a business process, that's making them uncompetitive. And they've tried various things, which means they've used kangaroo solutions and have not come up with the answer. So in complicated problems, you need to get the root cause and prove that you've got it. And then you can start looking for solutions. There's another type of problem, and that's called a complex problem. And a complex problem is one that doesn't necessarily have a root cause that you can go and find. For example, with COVID, there was a lot of work that needed to be done before they had some idea of how they could solve this problem. And it was a complex one, so they had to try different things. So for example, they try vaccinating everybody, and then they discover when they're doing that some people don't want to be vaccinated, that some people don't have enough vaccines available and don't have the money to buy them. So it's kind of like you experiment with solutions that seem to be at the root cause, and then you watch to see what happens, and then you've got to act again. So those are in complex situations, but 99% of the problems that we face in businesses when it comes around being able to achieve the results you're looking for are complicated problems. I've mentioned this before, but it's worthwhile mentioning again, that organizations tend to throw kangaroo solutions at complicated problems. And they will never really solve their problems in doing that. In fact, the way many processes have developed in organizations is that multiple kangaroo solutions have modified the processes over time until they're very complicated. There was a case where I worked in the Bank of Montreal in Canada, and at one time we were looking at improving the process for approving small business loans. And one of the things we discovered was a 75-year-old policy that was still in place, that had no place to be there. And one could only imagine that at some time it was a kangaroo solution to some problem that the bank had 75 years previously. That was before computers and all those things were in place. So kangaroo solutions are sort of adding to a process, almost like limpets that get onto the bottom of a boat. And eventually you have a huge amount of these shelled limpets and so on hanging onto the boat, slowing down its progress through the sea. So there tends to be businesses still using kangaroo solutions to throw at complicated problems. I just talk you through this because this gives you another view of how do you go about improving a process. We spoke about if it's unstable, the outcomes are varying. You need to stabilize it first. And when it's stable, the outcome is constant now, but maybe non-quality. And if it's non-quality, you need to make it capable, which is describing a process in which the outcomes are constant and of quality. But even a process that constantly produces quality might be inefficient. Throughput might be too slow for market demand. It might also be that it's becoming more and more expensive to produce the quality that you're looking for. And so we move into this whole area of efficiency. You've heard the word lean. Lean is about removing waste from processes and making them more efficient. And the efficiency that you really aim for is value-added only steps. So if you had that coffee maker that was filtering the coffee, you want to get it down to the steps that were now solved by an espresso. The reason why Melita still exists and makes a lot of money today with filters and so on is that not everybody could afford the Nespresso machine, and it's a bit more expensive to buy a whole lot of pods. So they would rather buy their own coffee beans and grind them and put them through Melita. So each company would be different in deciding exactly how efficient they want things to be. Do you want to get to the point of robotics or not? Is dependent on how much capital you've got and also the volumes that you need to do, and are the robots going to improve your quality and throughput? So the efficiency one is an ongoing one forever and ever. But you don't really start looking at efficiency until you have a capable process. And then the last one is you become near perfect. And the reason why you're near perfect is that processes always have the capability of being improved. So this is basically a high-level look at the way you would go through improving processes on an ongoing basis. So in summarizing the basic things about process thinking, which I hope by now you're quite excited about, is all work is a process. If you don't like the outputs, find the cause, invent and implement elegant solutions. I said to you that I would talk more about elegant solutions, and I might as well do it here. The word elegant comes really from us thinking about Audrey Hepburn's little black dress in the movie Breakfast from Tiffany's. It's generally looked upon as a dress that is so simple in design, and yet it makes the person look beautiful. And the purpose of it was to be a backdrop for the person's beauty. So it's a simple design, and the elegance comes from that it's beautiful. So people look at a little black dress or women in a little black dress and say, wow, that's really neat. So when we talk about elegant solutions in business, we're talking about a solution that is simple and that people can look at it and say, wow, that's neat. We didn't think it would be so easy to resolve. And there have been many occasions when teams who have been working on improving processes have presented to senior management. And when they presented some of their solutions, the management reaction was, oh, that's so simple. Why didn't we think about that years ago? And of course, the reason was that they didn't get down to the root cause and then use the discipline of coming up with the simplest, most effective solution. In later videos, you will hear more about elegant solutions. So the other factor that we've learned is that every process can be improved and every process has waste. The first step to make the process is stable and redesign the process to deliver quality. The next step is to make process efficient by removing unnecessary steps and dissolving the constraint. Continuous improvement is basically a habit that organizations can develop. And I'm hoping that you, at the end of this, as you start thinking more about processes, will in fact become a process thinker. And like me, standing in the shower one day, start thinking about the process of showering and how can I improve things. The other thing we learned was that new strategies are dependent on an organization's capability to deliver the strategic objectives. So it's really important for companies to make an analysis of the capability and make that a factor in the strategic planning cycle. There's a phrase that is used a lot, which is operational excellence. And operational excellence is just two words that mean the whole company's capability to produce the results that they need. And very often when you're looking at operational excellence, you're looking at an improvement at the company level as opposed to an individual process level. So those are the main learnings from process thinking, and I hope that it excites you a little bit to realize that there's, wow, so many different ways now of thinking about process. So thank you very much.